All right, hi everyone, and welcome to 6.3 Exponential Growth and Decay. Our learning goals today are we're going to write exponential growth and decay equations using models and examples, evaluate exponential functions, and analyze real-world scenarios that involve exponential growth and decay. So let's start with a little refresher. Does anybody remember what the exponential parent function that we learned last week is? Good. It's y equals ab to the x. It's an exponential function because x is in our exponent. All right, so exponential growth. What does growth mean? Growth means that we're going to be growing, right? It means we're going to be getting bigger. And when we grow exponentially, we grow really, really big, really, really quickly. So that means that our y value, because that's what it equals after we do our x to the x power, it's getting really big, it's getting big really quickly. And decay is going to be the opposite. It's getting smaller. It's not necessarily getting smaller super quickly because it's going to even out, but it does get smaller. So let's make some connections to our parent function. Y equals a times b to the x. I'm just going to give you these equations and then let's talk about what is going to be what. So exponential growth is going to be y equals a times 1 plus r to the x power. And decay is going to be, let's do this in red because we're getting smaller. Y equals a times 1 minus r to the x power. Well, that looks a little similar. It looks a little different to the parent function. Well, we now have our 1 plus r and our 1 minus r in our b's position, right? Yes, but we still have our exponent as an x, and we still have our initial a value. Well, let's list off what these things all stand for. X and y are still our coordinates. Good. A, does anybody remember what a is? Good, it's our initial value. And we have this new variable called an r. Well, this is going to be our rate because every time we have an exponential growth or decay problem, we're going to have a rate at which it is growing or decaying. It's going to be in percent form. So we're going to have a percentage rate in every problem. But what do we know about percentage rates? When we deal with percents and we do any kind of multiplication or division, we have to turn it into a decimal. So we're always going to write as a decimal. So if I have the percent 25%, what is this as a decimal? 0.25. What if I have the percent 3.2? Okay, I have to move my decimal 2 places, and I have a significant 0 right here. So that 0 has to be included. It's not 0.32, that would be 32%. In this case, we have to make sure we're moving that decimal twice. So what would 105% be as a decimal? Good, 1.05. All right, that should hopefully be a refresher on decimals. Yeah, turning percents into decimals. There we go. All right, let's jump right into our lesson. So a town grows at a rate of 15% each year. Currently, the town has 5,286 residents. How many residents will it have in 6 years? Okay, so is this an exponential growth or an exponential decay function? Good, it's growth, so we're going to be using our growth equation. I'm going to copy and paste it right here to help me remember that that's the equation I'm going to use. X, Y, A, and R. Those are my important variables. Remember, when we're doing our coordinates, X is almost always our what? Good, in this case you're dealing with years, so X is always time. So X is going to be our number of years. And we're comparing that to the population. Good, what did we say A was? Our initial value. So how many residents did this town start with? 5,286. And what is my interest rate as a decimal? Good, 0.15. Okay, we are going to plug in what we know. We know A and we know R. That wasn't bad. We're going to plug those into this equation. So I have Y equals 5,286 times 1 plus 0.15 to the X. So this right here, this right here is the equation that I can graph to show any X value over time. But what does our question ask us to find? Our question asks us to find, after 6 years, how many residents are in this town. So what am I going to do with that 6? Good, I'm going to plug it in right there. So I'm going to have Y equals 5,286. What is 1 plus 15 hundredths? Good, 1.15. And I'm going to plug that 6 into our exponent. We can type that into our calculator. 5,286 times 1.15 to the 6th power. When you do that, what did you guys get? 12,226.8. That 0.8 will round it up to 27. So what does this mean? After 6 years, the town has 12,227 people. Good, everything there made sense, right? We did all of our math, we used our exponents, we've used all of our previous knowledge about this, and we found how many people this town is going to have. All right, moving on. A car depreciates at a rate of 9.5% each year. If you bought a car for $23,000 3 years ago, what is it currently worth? So if it's depreciating, it is a decay equation. So I'm going to use my decay function. Excuse me. All right, what are my variables? X, Y, A, and R. Again, X is always going to be our time, so it's going to be number of years again. What are we comparing the number of years to? Car's value. A is how much it started at, which was 23,000. And it depreciates at a rate of 0.095. Good. Plug in what we know. Y equals 23,000 times 1 minus 0.95 to the X. Okay, we want to figure out how much it's worth today if we bought it 3 years ago. So that's my X value. So again, it's going to go in for my x right there. Y equals 2300, 23,000. Oh my gosh, I missed a zero up there. 23,000. What is 1 minus 0 point? Man, I struggled up here really badly. 1 minus 0.095. What is 1 minus 0.095? 0.905 to the third power. Okay, pause. Everybody pause. Let's take a look at what our b values ended up being. For my decay function and my growth function, what's the difference there? Well, the growth is greater than 1, right? And the decay is less than 1. So that's actually something that's going to happen every time. If we have an exponential growth function, our b value should be greater than 1, and our decay problem should always be less than 1, our b value. Okay, let's type that into our calculator and see what we get. 23,000 times 0.905 to the third power. Did everybody get 17,048.00? Good, so what does this mean? After 3 years, the car's worth how much? $17,048. Any questions? Okay, here is our challenge problem for the day. So you guys are going to take this and try it yourself. Go ahead and pause this video. Actually, I'll read it for you and then you can pause the video. When a video game first launched, if I had spelled launched correctly, 1.2 million people played it. Since then, the game loses 8.6% of its players to other newer games each month. After 6 months, how many players are still active? Let me add that in here. Newer games each month. So you can go ahead and pause this video. All right. Now that you've figured this out, how many players are still active after 6 months? I'm going to scoop this equation down because we're going to do something different for it. So are we growing or decaying? Good, we're decaying. So y equals a times 1 minus r to the x. My a is 1.2 million. So y equals 1.2 million times 1 minus 0.086 to the x. What's that x going to be that I can replace? Good, it's going to be 6. So 1 minus 0.086 is 0.914. We plug this in. Should get 699,614 rounded players. Could we have also said has almost 700,000 players? Yes, because is this going to be a perfect number? Probably not when we're dealing with this, but it's going to be very, very close. Okay, so how long will it take for virtually no players to play this game? So in this case, I'm still going to have the same equation, right? Same function. Y equals 1,200,000 times 0.914 to the x. But this time, I want virtually no players. So we can use, actually we are going to have to, because we can't plug 0 in, because 0 is going to be what we call an asymptote. And we've talked about that before. So it's never actually going to be 0, but it could be really close. We can use 1. But is this going to be my x or my y? X is my time, which is 6 months or however many months it is. So my y is my players. So what I want you guys to do, if it ever asks you to find a y value for this, we are going to actually go and we're going to graph this. I'm going to use Desmos. And we're going to type in our equation. Y equals 1.2 million. I missed a 2. 1.2 million times 0.914 to the x power. And I'm going to zoom out so we can see what's happening here. Okay, so now that I have my graph, we are just going to take this line and we're going to trace it until we get down to about 1 player, where my y is 1. Y is 1 right there. So it's about 180 months. Okay, so that's what we do when we solve for y. So I'm going to write this coordinate. When x is 180, y is about 1, which means that it will take about 180 months for the game to have virtually no players. Anybody know how many years 180 months is? 15 years, just for a fun fact. All right, if anybody has any questions, please feel free to ask about this. Otherwise, we're gonna go learn about the next part of exponential growth and decay in compound interest, which is going to be one of the most applicable uses for exponential functions that you guys are going to use as you grow up. All right, compound interest is this big, long, complicated problem or equation. But guess what? It's really not all that complicated because we have set values or values that are going to be given to you for each of our variables. In this case, we have a capital A, which is going to be our final amount. We have a capital P, which is our principal, which I might have spelled incorrectly. I'm not 100% sure. The principal is our initial value. It's our starting investment, starting price, whatever we start with. Kind of like what our A was in our exponential functions. R is still our growth rate as a decimal. Well, let's talk about n in a little bit. And t is going to be our number of years. N, though, n is something new. N is the number of times it's compounded per year. So when we deal with compound interest problems, we are going to have some keywords that are going to be thrown at you. And you're going to have to know what those keywords mean. So if it's compounded so many times a year, annually means it's only compounded one time. Semi-annually is 2. Quarterly is 4. There's, 4 quarters in a dollar. Bi-monthly means every other month. Monthly means obviously monthly, so 12. There are 52 weeks in a year, and we use 365 days as our calculation if it says daily. There are some other ones. You will not see them very often. Bi-weekly would be every other week. So 52 divided by 2, 26. I can't think of any other ones off the top of my head right now, but that's what we're dealing with. So let's just jump right in. I'm going to give you some values. We're going to plug them in and we're going to see how this works, because the math can be a little tricky because we're going to have some really big and really small decimals, but that's okay. So I want to find my final amount. If I start with $1,000, compounds semi-annually, so how many times? 2. At 2.5% interest after 5 years. Sounds a little complicated, right? But this would be like you're investing $1,000 into a bank account. You're leaving it in there for 5 years, and every year you're gaining 2.5% of it twice a year. So let's just plug it in. My equation is A equals P. What is my original principal? 1,000 times 1 plus, what's my rate? 0.025 divided by n. We said our n was 2 to the n, which again was 2, times t, which was 5. All right, let's start simplifying. That way we can type a nice, easier equation into our calculator. So what is 0.025 divided by 2? And when we add, we can just put a decimal. 0, 1, 2, 5. 2 times 5 is 10. That is our number that we're going to type into our calculator. 1,000 times 1.0125 to the 10th power. Means it's being compounded 10 times. And since we're dealing with money, we're going to go to 2 decimal places. So after 5 years, you'd have $1,132.27 in this account. You haven't done anything but gained $132.27 in these 5 years. Nope, not too difficult. Very good. And here is your class challenge. I want you guys to pick a partner, work these out, and then I'm going to go ahead and fill in our final answers here just so you guys can see. 3 is obviously going to be a personal choice. I just want you to tell me why. But you guys can pause this video, come back at the end, and you'll see the answers. Good luck.